Um, Computers can use a choice of different search algorithms to find information much quicker than humans. Two common search algorithms are linear and binary. Consider the list of 7 names. What search algorithm would you use will be best suited, basically, and justify. So, like, should you use linear or should you use binary? Well, binary is faster than linear. Um, I mean, is there situations where linear could be better? I don't know. But anyways, we want to go with binary. Uh, Binary. And the reason, well, it's just better. Um, I think the key word here is the sort of type of algorithm. Um, it belongs to the what's called divide and conquer family, which is a very efficient family of algorithms. Okay, now search algorithms. Um, yeah, yeah. Search algorithms work by comparing the list elements with a particular search value, known as the key. Fair enough. Um, List in order the names that would be compared until Natalia is found using the linear search algorithm. Yeah, so basically, okay, the linear starts with Amir, and that's not a match. So then it goes on and checks Dean. Dean is checked and it's not a match. And then Owen is checked. And then Helen is checked. And then finally, Natalia is checked and it stops. List in order the names that would be compared until Natalia is found using the binary search algorithm. Now, that's much more interesting than the linear one. Although I wonder if the marking is the same. So with the binary one, it might be kind of easier to draw it, but you start off with the middle. You can basically start splitting things in half. So you start off and you check Helen. Okay, so let me just maybe I'll just cross that out so not to lose track. And then, well, now I guess there's two choices here. You can check the left first or the right first. So like, maybe I don't want that. So we've got Helen. Mm-hmm. And then you split them in two. And then you would have to split again. So that would be Dean and Steve. Right. Although I'm not actually sure because it depends what they mean by that would be. Okay, let me just think 1 second before I start rushing ahead with this, make sure I don't make a mess of it. Yeah, I am making a mess of it because what I'm doing is I'm using a binary sorting algorithm is what I'm thinking of. But we have to remember, importantly, that this is already sorted. So I'm not sorting it, it's already sorted and I'm searching. So we start by checking Helen. And Helen, we can see in Python alphabetically, you can check that Helen is less than Natalia. So that means we don't bother checking here in the left. We start checking in the right sub array. So then we check the middle of this, which is Steve, and Steve is greater than Natalia. So when we check Steve, we now have to turn to the left, and there's only one entry left, which is Natalia. So I think it goes Helen, Steve, and Natalia. Yeah. A, B, C, D, E, F, G, H, I, J, K. Yeah, it is sorted. But can we use the fact that the list is sorted? I feel like we're supposed to, but does it actually explicitly say that in the question? I wish it said the list of sorted names. I really wish it said that. Okay. So it starts off by checking Helen, and you can see that Helen is too small. So disregard the left and just look at the middle of the right. Check Steve. Steve is too big, so disregard the right and check the left. There's only Natalia left. So you can see it's quicker, which is exactly what we said earlier. So that's good. Okay. And now, next one here. I think I can fit it here. Complete the table below to show the best and worst case time complexities for the two search algorithms. You can assume the size input is n. Oh, what's the symbol for worst? Is it the omega symbol or is it the theta symbol? It's the theta, isn't it? I always mix them up. Let me think. Oh, hang on. Do we not use the letters in the leave insert? O, omega, and theta? Let me check something here. Oh, strange. I thought O was for worst case. Hang on, let me check something here. Let me check something on my phone. O is for worst case. Omega is for best case. And theta is for average. So it looks like in the leave insert we don't use these symbols, huh? O is for worst case. That's for worst. Omega, that's for best. Theta, that's for average. Okay, so I guess we're just using O all the time. All right. The worst case for linear is if you have to check everything. And the best case is you get it the first time. Binary search, I guess it's the same. Worst case, you have to check the first one. Sorry, that's the best case. But the worst case is that you have to go until the end and you're half it each time. So it's a log base 2n, I think. Now, this is not fresh off the top of my head, so I'll just double check it. Best and worst case complexity of linear search. Yep, that's right. And then binary. Yeah, log n. And I guess since you don't care about proportionality constants, you actually could write any log here, which would be fine. What is meant by O1 time complexity? Only one operational check was needed, i.e. we found it on the first check, which would be very, very fortunate indeed. Okay. Yeah, all right. What's next now? We have some Python code, it looks like. So I'll copy the next part. We just have one page left. All right, let's see. The Python code below shows an implementation of a binary search function. In the code, there's one example of iteration, state on which line the iteration starts and ends. Fair enough. The iteration starts here, starts on line 6, and it would end here at line 14. That's the iteration block. Okay, so lines 6 to 14 are carried out as long as low is less than or equal to high, or because you can get out of this loop with the return will get you out of the loop, right? We're not going to continue the loop once a return is made, I don't think. Or when a return is made, which looks like, which happens when L mid equals V, because you want to get this else here. Yeah. Okay, that's not too bad, I guess. The return function contains two examples of return statement, line 14 and 16. What is the purpose of the return statement? What is the purpose of a return statement, not the return statement? To give a response back to the line that called the function. E.g., return an answer. I don't know, there's probably a better way of saying it. Explain the reason for length L on line 16. This is returned if the while loop completes without finding a case when L mid equals V, i.e. it's kind of like a fallback. Okay. A bit more code now. What have I got? State 1 advantage. Let's try and copy a bit more. And then there's, might as well copy this one over here. Then we're finished this exam. All right. Ah. Okay, an alternative implementation of binary search can be achieved using recursion as shown. Referring to the code above, describe two properties of recursive functions. Yeah, so I think one thing you need to have in your recursion is what's it called? Stop case. I think that's it. And also, importantly for the name, is the function needs to call itself. So I'll make that property 1. The function must call itself in its own definition of itself. That's one for me. That's one thing. And stop case or base case or something. The function must have a base case. This is a situation when to stop calling itself. Okay. State 1 advantage and 1 disadvantage. Well, I think 1 advantage is that it's a divide. It can be used for like divide and conquer, which can be efficient. And in fact, in some situations, I think it can only be done recursively, perhaps. It's sometimes easier to define a solution or problem recursively than explicitly. Disadvantage is, I guess, you could be stuck in an infinite loop. Is one problem. Some problems are easier to define and solve with recursive functions and programming. Yeah. I think that's part. Like I think Fibonacci sequence is a good example of it. Like it's very easy, or factorials or something, to define the factorial function recursively. It avoids using iteration as well, if you consider that an advantage. But a disadvantage is, and I remember my programming degree, we had to kind of time measure different algorithms and their memory usage. And one thing I do remember, which surprised me a lot, is that recursive functions can use up a lot of memory, can use up a lot of memory. I.e., I think it's called like Stack Overflow. There's just too much to keep track of. There's too much to keep track of for the computer. Because you kind of have this potentially exponential growth of exponential growth. So like think about it, if you have some recursive function and perhaps it calls itself twice, then each time the function is used, it doubles memory usage. So I think I remember seeing that with one of the divide and conquer ones. Anyways, okay. Given a list of names initialized as shown below, write a line of code to call the function binary search 2 to find Natalia. You should store the result of the function in a variable called result. Okay, so result equals binary search 2, and we need VL low and high. Bum, 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 bum. What do we need to set? Okay, let's just establish which is the list. So L is obviously the names, okay. And we are looking for L mid to equal B. So B is the target. So that's Natalia, comma, names. Now, low and high. Do I need to set them myself? I have to, because they're not set here. So how is low and high working? If low is more than high, return the length. Oh, is it checking? If low is more than high, return the length. Mid is low plus high. Okay. Mid is low plus high. So is it just the... Okay, is it like where you want to search? So for example, 0, 1, 2, 3, 4, 5, 6. So if you have 0 and 6, if you put these in backwards, it returns the length. Okay, I'm not sure what's going on here. But mid 0 plus 6 divided by 2, so that's 3. And if L3 is more than V, then you want to search the right. And if it's less, you want to search the left. Okay, so low here would be 0, and then that would be 2. Okay, and this one here would be 4, and that would be 6. Okay, so yeah, it's what you're searching. So it's kind of weird it doesn't have default values in. I'll just put in 0 and 6. Yeah. Yeah. I don't know. Should it not have some kind of situation where the user, if they don't specify low and high, it defaults just the first and last value? And then you can pass low and high in recursively within the function? I'm not 100%. I think that's what's going on here. Okay, and that is the end of the paper. I did more than what I had to, right? So like in section B, I only had to answer 2. So I answered all 3. So I guess I'd get the marks for the best 2. And then likewise for section A, there was 12 questions and I had to answer 9. So the best 9. Though I wonder, would me doing all the questions have compensated and resulted in a decent grade? I don't know. I don't have the marking scheme. I've never done this exam before, but I thought I'd give it a shot and share it. Thanks for watching.